Hi everyone. In this video I'll be showing to you the results of the tool that I wrote, which recognizes handwritten digits. In this tool I have used a neural network which takes as inputs handwritten digits, studies the input and then tries to predict which digit it actually is. Our training set has 5000 training examples, where each training example is a 20 pixel by 20 pixel grayscale image of the digit. Each pixel is represented by a floating point number indicating the grayscale intensity at that location. Now that I have explained to you the inputs, I'll briefly go over all these files that you see over here. Now if you are too eager to see the results, feel free to skip the video by a couple of minutes to see the results directly. Now the training starts with this function right over here. It's called train nn stands for neural network. It calls It reads the input files, which is input data, and then it calls rand initialize weight to randomly initialize the theta parameters, which is the weight of our neural network, and then it calls fmincg. This particular file has the algorithm which trains our neural network, and this file then calls the nn cost function multiple times to get the cost and the theta parameters, which are the weight of our neural network. The cost function makes use of the sigmoid and sigmoid gradient files to calculate the cost and the partial derivatives of the cost function with respect to the theta parameters, which is again the weight of our neural network. And when all the iterations are finished, fmincg returns the trained parameters, the weights of our neural network, back to train nn, and then this train nn stores the weight that we got by training our neural network in the trained weights file. Now it does take a couple of hours to train the neural network. So in this video I'll load the trained weights directly into display NN results file. Since I have already trained my neural network, I have this ready. I'll load it directly into display NN results, and then display NN results will call display data and predict to show us how our neural network is doing. Now let's see our neural network in action. So I'll start. So this is the input that our neural network is getting. I don't know whether you guys are able to see it properly or not. Let me zoom in a little bit. So as you can see, this is 4, this is 6, this is n. So all these handwritten digits our neural network is getting as inputs: 3, 2, 4, 0, 0, 6. Now before we move ahead, I'd like to discuss the mapping. Digit 1 is mapped to class 1, digit 2 is mapped to class 2. The only exception is digit 0 because it's mapped to class 10. Now the reason I have done it this way is because Octave does not have any zero index, and all this code has been written in Octave. And Octave starts from index 1. So in order to stay compatible with the Octave indexing, I am also starting with class 1, then mapping digit 0 with class 10. What that means is that when a neural network thinks that it got the handwritten digit 1, it will predict class 1. When it thinks that it got the handwritten digit 4, it will predict class 4. But for 0, it will predict 10. That's the difference, and let's start now. So these are our inputs. Now our neural network is predicting that it's 7. Now for digit 7, let us see whether we got 7 or not. As you can see, this is a 7. Let's check again. So now our neural network is saying that it got the digit 2. Let's see what we got. So it's 2. Now it's saying it's 1. Is it really 1? Well, it's 1. So the neural network is doing its job pretty accurately. See, so for 0 it's saying 10. Did we get 0? Well, it's a 0 for sure. Moving ahead, it's saying 9. What did we get? We got a 9. It's a very distorted 9. The person who wrote this 9 does not have a very good handwriting. Let's move ahead. It's saying digit 6. It's 6. Again 9. This 9 is a little bit better. Now it's saying it's 5. We got 5. This 5 looks a bit like S, but then since we are okay, we got a 9 again. So this 9 is very well written. This is a perfect 9 and 1. So as you can see, our neural network is doing a pretty good job. We'll now quit, and as you can see, the accuracy of the network is 97.52%. So this is how a neural network works to predict the handwritten digits. Hope you guys liked how it worked. Thank you.